Hello panelists, hope you are all doing good. Today I'll be presenting a paper titled Exploring Usage of AWS Lambda in Data Processing. Abstract. Cloud computing is changing game all around the industry. It's delivering computing resources such as storage, processing power without investing in, and managing physical infrastructure, offering a more flexible and cost-effective approach to meet computational demands. Serverless computing is a cloud computing execution model where cloud providers automatically manage the infrastructure needed to run applications and scale. This paper examines use of AWS Lambda in data processing, the leading serverless computing service of AWS. Our study will explore the architecture integration of AWS Lambda with other AWS services, real-world use cases, proposing best practices for data processing. This research will provide a complete understanding of AWS Lambda, and finding here are a valuable resource for people looking to unleash the benefits of AWS Lambda in a scalable and high-performance cloud-native application architecture. Keywords: Amazon S3, AWS Cloud, SNS, SQS, Kinesis, DynamoDB, CloudWatch, KMS, Secrets, Redshift, EventBridge. Introduction of Amazon Lambda. AWS Lambda, a key service for building scalable and cost-effective applications, was introduced by AWS back in 2014. Applications based on Lambda are event-driven architectures and can handle many complex tasks like scaling and infrastructure management. It can also be useful in understanding the troubleshooting and monitoring tasks. Lambda mostly used in the four categories: 1. Web applications, 2. Web and mobile backends, 3. Data processing, 4. Parallelized computing tasks, and IoT workloads. AWS Lambda free tier includes 1 million free requests per month, 400,000 gigabyte seconds of compute time per month, and 100 gigabytes of HTTP response streaming per month, beyond the first 600 MB per request, which are free. Literature review. There are multiple AWS serverless services are available like AWS Glue, Step Function, Lambda for data processing. Choose the right service is very important while designing the data pipeline. Lambda can be useful while loading very small volume of data in a batch into target table from source. It can be used to trigger AWS Glue, which is extract, transform, load pipeline to transform and load huge batch data. Lambda function can be called from AWS Step Function to load huge volume batch data in multiple loops. AWS Lambda can be triggered with lots of streaming services like Amazon Kinesis or Amazon DynamoDB streams. Architecture of AWS Lambda. Few important pieces of AWS Lambda are Lambda function, triggers, IAM access, logging and monitoring, deployment, concurrency, environment variables, VPC, which is virtual private cloud configuration, and Lambda destination. First, Lambda function. Lambda function is the heart of AWS Lambda. It can be written in different supported programming language like Python, Node.js, Java, and Go. It's the place where business logic resides for AWS Lambda. It can consume events as source, process it per business logic, and publish it to other services if required. Triggers. As Lambda is event-driven, the following are the most common event that can trigger Lambda. 1. Amazon S3 event notification for file upload and or deletion. 2. A REST API call. 3. Amazon DynamoDB table stream. 4. Amazon Kinesis for real-time streaming data. And 5. Any other custom events like generated by CloudWatch. Third, IAM access. Lambda functions should have required IAM access roles to perform all duties. The role of Lambda function should have access of all the services that it's consuming from or publishing to. Next, AWS Lambda logging and monitoring. Lambda publishes logs to AWS CloudWatch. Lambda creates CloudWatch log group for each function and each invocation created log stream. One can get various metrics from CloudWatch like success, failure, performance, etc. It can be integrated with AWS X-Ray for various other matrices, and X-ray tracing should be enabled. Next, deployment. Most common way to build Lambda for deployment is using deployment packages, where all the codes and dependencies are packaged in a specific directory structure. In case of deployment packages, external dependency can be packaged with Lambda code. Otherwise, it can be added using Lambda layers. Lambda can be deployed using AWS Management Console, CLI, or CI/CD pipeline. Next, concurrency. Lambda can scale horizontally by spinning up multiple instances in parallel. It helps to speed up the process and boost performance. Lambda supports three kinds of concurrency. One, it is a concurrency. It's the maximum number of concurrent instances that Lambda function can run. This number is maximum 900, and configuring it is always a good practice. Two, unreserved concurrency. If there is no concurrency number is declared, Lambda function takes a default setting of 1000 per account per region as concurrency. Third, provision concurrency. This is used to reduce latency and keep Lambda available in one pool. This is to let AWS know beforehand how many Lambda functions process needs at a certain point of time, so that numbers would be readily available whenever required and avoid the cold start time. Next, environment variables. This is a very useful feature to pass any variables like KMS key for your encryption, secret names for database credentials, or log group name to create CloudWatch log, etc. You can specify these variables while deploying the Lambda. Next, VPC configuration. Lambda functions are deployed to VPC. Lambda manages resources named hyperlane ENIs, which it is used to connect from Lambda VPC to an ENI of a VPC. Lambda destination. Lambda can publish its success or failure status to destination without writing any code. The destination can be AWS SQS, SNS, EventBridge, or any other Lambda. Here comes the Lambda architecture. So first, from the left-hand side, first was event, and then it triggered the Lambda. And then Lambda is ready to execute in the second box. Third box, Lambda allocates custom resources for execution. And the bigger box where Lambda start execution. First, it checks IAM permission. Second, connectivity of all required resources, like they reside maybe another VPC or someone like that. And then Lambda execute business logic. And while doing the processing, it logs all the information at CloudWatch. And at the end, it just doing success or failure to its destination. Number 4, transform and load data into database using Lambda. AWS Lambda can transform data per business logic written in Lambda function. AWS Lambda can also be used to load small volume data into database like AWS Redshift. Lambda can execute copy command to load data from S3 to database. It's quite easy to integrate Redshift with AWS Lambda once IAM access and database credential are handled correctly. Lambda has a limitation of timing out in 900 seconds, and due to that, data processing or data loading volume shouldn't be too high so that it may cross 900 seconds. For larger volume batch, Lambda can trigger AWS glue job or can be called from step function. Below figure you can see file is uploaded to S3 bucket, then it triggered S3 event trigger, and that triggers a Lambda function, and then Lambda function execute a copy statement, and that copy statement load data into Redshift. Number 5, invoke AWS Glue using Lambda. As Lambda has a timer limitation, AWS Glue is used widely to process ETL pipeline. AWS Glue is a serverless, fully managed AWS offerings, and it's able to discover, catalog, transform, and move data between data stores. It has some very exciting features called crawlers, data catalog, etc. Crawler can automatically discover catalog metadata from sources and creating metadata tables in AWS data catalogs. Data catalog supports S3, Redshift RDS, and other JDBC compatible database as source. AWS Lambda can be used to trigger a glue job based on some event. As an example, once file will be uploaded to S3, Lambda will be triggered and the Lambda will invoke a glue job. Lambda can pass all required information while calling glue job as parameters. So in the below image, you can see there's S3 bucket, file is uploaded there, and that triggers a Lambda function. Lambda function triggered a glue job with required parameters, and this glue job transform and load data into Redshift. Next, Lambda and step function. AWS step function is very popular service that can call AWS Lambda to load huge volume data in multiple loops. Step function can build serverless workflows by defining a series of state machines that represent the steps in your workflow. Each state of step function performs a task and it can decide the next state based on condition. Step function has a choice state to decide next step based on previous step. So step function can call same Lambda function multiple times to load huge volume data. Suppose if a batch has 100,000 data and Lambda can load 25,000 data into database without timing out, step function should call Lambda 4 times and each time 25,000 data would be loaded into database. Choice state should indicate that 4 Lambda iteration required to entire batch. For invocation, step function can be integrated with AWS Event Bridge to access any event notification like S3 event trigger and can start execution. So below image, you can see file is uploaded to S3 bucket. Then S3 event notification go to Event Bridge. Event Bridge triggered the step function and the step function load data into AWS Redshift. Next comes streaming data. Point number 7, streaming data processing using Lambda. Lambda can be useful while processing real-time streaming data. Lambda with Amazon Kinesis data stream. So AWS Lambda and Kinesis can process real-time streaming data like clickstream, transaction order, IoT device, logstream, etc. Lambda can read data from Kinesis stream and store it to some database like DynamoDB, NoSQL. Multiple processes can use this data from database per their need. The IAM role used for this purpose should have all the required access of accessing Kinesis data stream and DynamoDB. So below picture, you can see client application that's streaming data coming to data stream, Lambda function processing the data and then storing into NoSQL database, which is DynamoDB. Next, Lambda with Amazon Kinesis Data Firehouse. Lambda can be invoked by Kinesis Data Firehouse for transforming incoming data and delivering to destination. So if you need any transformation in Kinesis Data Firehouse, you can use Lambda function for it. So if you look at the figure, there is a Kinesis Data Firehouse, and from where Lambda consumes the data for transformation, and after transformation, it sends back data to Kinesis Data Firehouse. Next, DynamoDB stream and Lambda function. DynamoDB streams capture a time-ordered sequence of item level modification in a DynamoDB table and can trigger events to respond to these changes. It allows you to build applications that respond to changes in your DynamoDB table in real time. Lambda can be triggered by DynamoDB stream, do the modification, and store data into S3 or some other places. So if you look at below figure, the DynamoDB stream processing using Lambda function, then Lambda function storing data into bucket. Here comes the conclusion. AWS Lambda is a revolutionary technology of serverless computing that offers unparalleled scalability, cost efficiency, and flexibility to developers and organizations. Throughout this research paper, we have looked into use of AWS Lambda in data processing. We have explored the batch processing and real-time data processing both. AWS Lambda is very cost-effective due to its pay-as-you-go model and seamlessly integration with other AWS services enhance the overall capabilities of Lambda. AWS Lambda offered numerous advantages. However, it is essential to acknowledge some challenges like potential cold start latency and certain limitation of execution time and resource allocation. In conclusion, AWS Lambda is not just a technology choice but a strategic decision for organization aiming for serverless computing. As cloud computing evolved, AWS Lambda is a front runner for its capabilities and one of the most useful services in serverless cloud computing. That's all from my end. Have a good one, everyone.